Dobrodošli nazad. Počinje nova sesija Sinergije 21 pod nazivom What can you do with Azure Synapse Analytics?
Thank you all for joining this when to use Azure Synapse Analytics. So before we go when to use, let's talk about why Azure Synapse Analytics. So the burden of data architecture. So as you probably have already, whoever worked on data analytical solutions, data architectures, are aware of these challenges. So you have data coming from different data sources, be it from business apps, log streams, unstructured, structured data. And in order to get that data into a central location for your analytics has been a big challenge, right? So you have these different silos. You need to have some tools to integrate, do data integration into your data warehouse. You need to have a dedicated data warehouse for your relational data versus data lake for unstructured data and data science tools. So these are all different silos, and you have a lot of data movement going back and forth that causes a lot of challenges, and not to mention about the security and latency and performance. And also on the consumption side, different types of reporting, BI, app tools. And when you're talking about the enterprise data architecture, you cannot forget these, right? The security and privacy, governance and compliance, availability. So all these are challenges that you handle day in and day out when you're working with in a data architecture. And Synapse Analytics is targeted to minimize, if not eliminate, those challenges that you encounter with these different data silos, right? So it's the first unified cloud native platform for converged analytics. It provides simplicity at scale. So unified platform for data warehousing or big data processing, data integration, everything in under one umbrella, called Synapse Analytics. Single pane of glass management, monitoring, and security. So all those enterprise level requirements like integration, management, monitoring, security, CI/CD, all that under one common single pane of glass, so to speak. And runtimes for both structured SQL relational data versus unstructured or semi-structured big data. So runtimes for SQL and Spark Analytics for the big data combined into one with seamless interoperability between these runtimes, and low code experience for data analysts, citizen, data scientists, and data engineers. So all this is provided under one common platform called Azure Synapse Analytics with various analytical runtimes and with the common meta store between data warehouse, data lakes, stream analytics, and of course Synapse Link. So we'll talk about Synapse Link, where you can pull the data, work with data from Cosmos DB, Dataverse, and very soon with SQL DB as well. So all that comes with a unified experience of using Azure Synapse Studio for handling, managing, and combining and working with all these different components with one common web-based platform. So that's how Synapse Analytics makes it easy to minimize those challenges, come up with the data warehouse or lake house, as we call it now. So all that can be handled with a single platform. And not to mention about the consumption target. So not only Power BI, machine learning, but all other types of interactive BI reporting tools that can be used seamlessly with this platform, right? So when we map this to a physical layer, So this is what your common modern data warehouse, modern data lake or lake house, if, as you may call it, architecture, where you have these, different data sources, data coming from different sources, being ingested, pulled into your data warehouse, data lake house platform. So as you see this, we are seeing like showing up as different components, but these are all basically part of Azure Synapse Analytics. You have Synapse SQL for streaming, Synapse pipelines for ingesting the data from different sources, and data lake in tight integration into data lake storage for Synapse, Synapse SQL dedicated pool. So we'll talk about this different Synapse SQL layer and Spark, and Power BI, Azure ML. So these are all different components you'll be using as part of your modern data warehouse architecture, but these are all part of a single platform offering called Synapse Analytics that provides that common single pane of glass to be able to combine all these different functionalities and components into under one umbrella. Okay, so and if you take it further, so the Spark based, again, there's not one or the other. So like I said, we have SQL and Spark engines combined into a Synapse Analytics as runtimes, and you can work with them together. It's not either one or the other. But yeah, so when you have a Spark based functionality, when you need like big data, functionality that is required. Spark engine analytics using Spark engine or Spark structured streaming and whatnot. You can use Spark components as opposed to SQL components. And again, like I said, combination of those two can be integrated into your data warehouse or lakehouse architecture using Azure Synapse Analytics functionality. All right, so let's talk a little bit about the Synapse Studio. So what the functionality available in Synapse Studio that helps you with facilitating all this and being able to work with Synapse Analytics from single platform. So let's look at quickly some functionality available in Azure Synapse Analytics Studio and how you can use that for your data lakehouse or data warehouse data analytics use cases. So Synapse Studio, most of you, some or at least some of you may have seen this when you create a Synapse Analytics service in Azure. You can connect to Azure Synapse Studio, which is a web-based front end for your uh, data management, development, and monitoring needs of Azure Synapse Analytics. So it's a single place for all your data engineers, data scientists, IT pros to collaborate on enterprise analytics. It's divided into different activity hubs, as you see here. So data, develop, integrate, monitor, manage, all these are the different hubs that provide different functionality. So we will look at individually each of those and how you can use those. So if you look at Data Hub, so you have your workspace, which includes your databases, be it SQL dedicated database pools or serverless pools. We'll talk a little bit more about those in the upcoming slides, or Spark pools. You can create and you can manage them under Workspace. And then under the linked tab in the same data hub, you can link your blob storage, Cosmos DB, Data Explorer, Data Lake Storage, Gen 2. So all these can be linked, quote unquote, into your data hub. So you can manage data from all of these different linked services with your Synapse Analytics, and join this data with your SQL pools, for example, or pull the data or manage the data seamlessly by adding them all into one place, as opposed to you go to a different tool for different storage or different functionality. Instead of that, so everything is provided in one common space under Data Hub. So if you look at a little bit, a quick example here. So for example, if you add data lake storage Gen 2 as a link service in your Data Hub, you can explore the data sitting in any of the files sitting under data lake storage Gen 2 by simply, you can preview the data. So if let's say you have a product.csv file sitting there, you can simply preview the data uh, for that uh, for that file or files by simply clicking on preview, and you'll be able to explore the data without pulling it into any engine per se, right? Same thing, you can also run ad hoc queries of the data. So if the data sitting in the data hub, you can simply say, create a script, select top 100 rows, and it automatically generates a SQL, T-SQL, familiar T-SQL syntax to explore the data by using a T-SQL query. And you don't have to write this query yourself. You can automatically generate that. Same thing with the Spark side. So you can explore the data using Spark by simply, creating a new notebook and loading the data into data frame, and it automatically generates the Spark code for you to to explore the data. So that's how. So any data, be it CSV or Parquet or even JSON, the data sitting in your Azure storage, ADLS, data lake storage, you can explore the data, preview the data by simply connecting to your studio and using the built-in functionality to explore the data seamlessly. Not only that, but you can also, it's not just ad hoc exploration, but you can actually create external tables. So you can, from the same exploration tab, by right-clicking on a file, and you can create an external table, which will automatically generate the code for creating an external table for that file. So from that point onwards, you can directly reference that table for your exploring the data sitting in that data lake. So by just running a select query on an external table, that external table is pointing to the data sitting in your data lake store, and it will automatically pull the data from that external storage without persisting, without materializing the data into any traditional relational data store. All right. In the same data hubs, you can also see databases, like I mentioned. So you have Synapse SQL support in addition to Spark support inside Synapse. So you can create any database, dedicated SQL pools you create in your Azure Synapse Analytics workspace can be managed and handled from this data hub and the databases tab, or be it serverless or dedicated even Spark database that you create, or all can be viewed and explored and managed all from that data hub in Azure Synapse Studio. All right, so just a little bit more on that. So databases, you can, same thing, just like how you could explore the data sitting in data lake store. The data, if you pull into a relational structure in SQL pool, for example, you can also generate SQL scripts from the data directly, or you can also pull it into using PySpark code into a Spark data frame. So you can manage and handle and explore the data in one analytical runtime into another by simply using the databases data hub. And the last one in data hubs is data sets. So you can create data sets and then you can use that to orchestration of your data using the data sets. We'll talk about pipelines that's upcoming, that you can create pipelines to handle this data. You can use the data sets as sources or sinks to manage and manipulate and copy data from one source to another destination, source to sink, using these data sets. You can configure these data sets and use them as part of your pipeline. Now, moving on from Data Hub to Develop Hub. So this is where most of your developers, your IT folks will be spending time, right? And that is also, so you don't have to go to a different tool to develop your SQL Analytics or Spark Analytics. You can do all that from your Azure Synapse Studio using under the Develop Hub. So we looked at the Data Hub, and if you look at the Develop Hub, uh, you have multiple languages to analyze your data under one umbrella, be it SQL scripts or notebooks with different languages, be it Python, Scala, and things like that. You can switch over notebooks and scripts without losing its content. You can save that data, and you can use IntelliSense code for reliable code development. You can even get visualizations, as you can see on the screen here. So you can get visualization of your data right from your Develop Hub. It's not just getting the data in a tabular format, but also you can visualize the data, generate graphs and things like that. And you can organize your code artifacts into different folders and subfolders to help with your code deployment and CI/CD. So all that is available as part of your Develop Hub. So like I said, SQL scripts. So if you look at when you are developing SQL scripts, you can write your SQL code, or you can generate your SQL code, and you can have the data showing up as a table versus as a chart, and you can export the data into different formats. All that you can use through Develop Hub. Same thing if you are familiar with the notebooks, if you are working with Spark engine, you can create notebooks and use different languages like Python, Spark, or .NET, Spark SQL, all of that to be able to create your notebooks and work with your data using the Spark engine available. And the notebooks, you can configure those notebooks. You can allow developers to control how many resources to be devoted for running their notebooks, of course, with right permissions. You can also provide you have quick links to monitor the session, the Spark session and Spark history. All that is available in the Develop Hub. So yeah, so I'll just quickly. So there's notebook functionality that is available from the Develop Hub, and the data flows. So you can also create run data flows for transforming and managing your data. So data transformation is one important aspect of your data analytics. So you need to create data flows task and transform the data from one type to the other, or moving data or partitioning. So any types of ETL you would like to do, you can use data flows that built into Develop Hub to be able to do the transformation of the data, which provides a code-free experience um, for your data transformation needs. So these are some of the data flow capabilities available. So you can handle upserts, updates, you can add file handling, data lineage, partitioning, and then hash functions. So these are all different types of data flow capabilities available to help with your data transformation needs for moving data and transforming data as you work with your data coming from different sources for your data analytics. And then consuming. So yes, you load the data, you manage the data, you transform the data, but now how about generating reports and consuming the data? So Power BI is one of the common reporting tools you would be using for um, consuming and generating reports, analytical reports out of the data. That is also integrated into Synapse Analytics. So now you don't have to go to a different, your Power BI desktop or Power BI service to create reports or manage reports or update or explore the data. You can use in the Develop Hub. You can the Power BI is integrated into it, so you can create reports. You can access your published reports. You can update them, and you can visually explore and analyze all that is available under the Power BI tab under the Develop tab. All right. So yeah, so this is another, this is an example of how a report. So you can pull the report that it's previously created. You can view it. You can edit it, just like what you can do with a Power BI desktop or Power BI surveys. That you can do it with a Develop Hub. And you can create not only explore existing reports, but you can actually create new Power BI reports and display and manage them from the Develop Hub. Last but not least, the CI/CD functionality of Develop Hub. So, of course, as you work with this data, the CI/CD functionality, code deployment functionality is critical for being able to, as you develop data. So the CI/CD functionality is also built in. So with ADO, Azure DevOps, and GitHub integration, you can create and you can deploy. You can work with your code. You can use CI/CD functionality you built into Azure Synapse Studio. And then for those of you familiar with the Azure Data Factory, so this should be familiar. So the pipelines you can, as you move data, as you work with your data, you need to ingest, transform, and load data into from different sources for your data analytics. So that can be done also using pipelines functionality built into Integrate Hub in Synapse Studio. So you don't have to go to a different tool like Data Factory or something. So it's all built in, and you can see different types of transformation functionality available, moving, transforming Azure Functions, batch service, etc., that you can use to create your pipelines and transformation activities within Integrate Hub in Azure Synapse Studio, which provides that seamless single pane of glass experience for your working with your analytics. So the pipelines, for those of you not very familiar with pipelines, it's basically it provides the ability to load data from different sources to using a desired link service. So there are 90 plus connectors available to connect and pull and work with the data from different sources, be it Amazon Redshift, S3, Blob Storage, Cosmos DB, and like that. There are 90 plus connectors available to work with different types of data using your Synapse Analytics. So at scale, so once you create these kind of pipelines, you can create you can orchestrate your data movement, data transformation from any source into any of your analytical runtimes inside Azure Synapse Analytics. So you can create on-demand or scheduled activities inside a pipeline to trigger based on a schedule or trigger based on an file availability, for example, and then have that the pipelines run to perform different activities and using self-hosted integration runtimes or Azure integration runtimes to connect from the data, be it in on-prem, different sources in on-prem, or other Azure services. So you can create this integration runtime to pull and manage the data from different sources into your pipelines and perform transformations and other activities to get the best out of your Azure Synapse Analytics. And then, of course, all this is, what we were talking about before. Some of the challenges are about monitoring and managing your enterprise level analytics. So the Monitor Hub is also built into the Synapse Studio, which can provide the single pane of glass to monitor and orchestrate activities. So be it to monitor your pipeline runs, trigger runs integration, or Apache Spark, SQL request, all that is built into the monitoring is also built into to the Synapse Studio. So you don't have to use a different monitoring solution, or you don't need to go anywhere else uh, because of that single pane of glass experience here. Same thing with manage. So you can manage all, be it your SQL runtime or Apache Spark runtime, or if you create a link services, or your triggers that you create for pipelines, and even security, all that can be, and your source control, everything can be managed from the Manage Hub inside Azure Synapse Studio. So this is how, so all this Synapse Studio functionality built into Azure Synapse Analytics can help you with your with your analytics, data analytics, with less overhead and less challenge, minimize your challenges that you would have otherwise when you have to go to different tools for doing different things. So all that burden is minimized by using Synapse Analytics, and with the help of this Azure Synapse Studio, which can help you with managing everything from one, again, single pane of glass experience. All right, now let's look at Synapse SQL functionality and how to use and when to use this Synapse SQL functionality for your data analytical needs. So, like I said, there are Synapse SQL and Spark runtimes available within Synapse Analytics. So if you look at the SQL runtimes, so it provides that rich surface area of uh, T-SQL language for data analytics. It supports large number of languages and tools, as we have seen before, not just SQL, but other types of language as well. But yeah, so here we're talking about specifically SQL language, enterprise grade security. So it provides enterprise grade security that is critical for your Synapse for your enterprise data analytic needs. So there are two different runtimes available as part of the SQL. Dedicated SQL pool, for those of you familiar with the previous SQL data warehouse. So this is what we had. So it is now called as dedicated SQL pool. It provides that modern data warehouse architecture with the indexing and caching functionalities for performance. You can import and query. You can either import the data from external into a relational structure or query the external data. You have workload management capabilities to provide better concurrency and performance balance for your SQL analytics. So all that is part of the dedicated SQL pool. On the other hand, the serverless SQL pool, which helps you query that external data to provide for that lake house scenarios we talked about. So to be able to query the data in place in sitting in data lake storage, you can use that serverless SQL pool for without any dedicated compute engine, which means you don't have to pay for a dedicated engine. You don't have to dedicate resources like in dedicated SQL pool. By using serverless SQL pool, you can create a virtual data warehouse, logical data warehouse on top of say serverless SQL pool, where you can model the raw files as virtual tables or views. And you can also do data transformations easily using serverless SQL pool without having a dedicated compute engine uh, needed, right? So this dedicated SQL pool functionalities. Again, for those of you familiar with the traditional SQL Server or SQL Data Warehouse, the all those benefits of what you get with a traditional SQL engine is available as for a dedicated SQL pool. So if you're working with the traditional relational data or data coming from relational data sources like Oracle or Teradata, Netezza, so this is going to be a natural choice for you to pull the data into a dedicated SQL pool, and that dedicated functionality is available via advanced storage system like column store indexes, table partitions, distributed tables, materialized views, and caching, result set caching, all that functionality to give you a better performance for your relational data, no matter how big that is. And it also provides standard T-SQL querying functionality with the different types of querying, windowing aggregates, approximate execution, JSON data support, machine learning models. All that is provided as part of a standard familiar T-SQL functionality. Complete SQL object model, again, following the traditional SQL functionality. You have tables, views, stored procedures, functions, all that is available as part of the dedicated SQL functionality. But then when you move to the other side of the serverless SQL functionality, like I said, it's an interactive query service with that provides that enables you to run standard SQL queries over any file in Azure storage, right? Be it CSV or Parquet or JSON, you can query that data in place, and you can actually use a BI layer on top of that. So Power BI or Azure Data Studio, SSMS, Management Studio, you can query your Synapse SQL Server SQL pool from any of these tools, and that internally connects to your Azure storage and query the data in place to provide you that serverless analytics without having a dedicated compute, and hence it provides you better cost versus performance benefits. So there is no infrastructure, so which means no upfront cost, no resource reservation. You only pay for query. So for those scenarios where you want to have the data sitting in its native format in your lake house, and you want to run analytics on top of that with SQL like functionality, this is going to be your best option to use a serverless SQL pool to be able to run those analytics using familiar T-SQL functionality. So what are the recommended usage scenarios? When do you can use serverless? For quick data exploration, to easily explore schema and data in files, or it supports various file formats. Like I said, you have direct connectors available to Azure Storage for large BI ecosystem, so you can directly run your BI, run your reports directly from the storage. But you can also create a logical data warehouse without persisting the data. You can create metadata on top of your raw files. So you can model your raw files as virtual tables or views, and then you can use any tool that works with the typical SQL server to analyze those files. For those tools, it looks like your standard SQL, but you created a model, a virtual tables and views, and you're working with that, which means you're actually handling your data sitting in your storage in your lake house with your data lake with your serverless engine, right? So but because of that logical data warehouse and virtual layer, you get enterprise grade security model. So you can grant permissions, give access controls and everything to provide that enterprise grade security model. And then, of course, data transformation. So you can also use this serverless engine to transform data in place. You can, for example, transform CSV to Parquet, or move data between containers or folders or accounts, or run queries and then persist the data, that the result of a query, into external storage. So you can do all that using the serverless engine. Right, so there are some examples here. So we have seen before, so you can actually query the data. So SQL on demand. So this is your serverless engine that you are running with a familiar T-SQL to query the data sitting in a storage. Right? You can all formats, be it CSV or Parquet or JSON. You can query the data no matter what the file format is. And then you can also, you don't have to know the schema or structure of the files or data. You can do automatic schema inference. So if you have the data sitting in your data lake store and you don't know what the structure for that is, yeah, so it'll automatically infer the schema. It'll automatically determine the columns and types of data stored in external files, and provides you the output of that file in a structural format. You can also use the folder structure. You can partition the data. If you have large amounts of data sitting in your data lake, you can use open row sort functions and file path functions to access the data in a specific folder or partition. And you can group by using the file path function. So all that provides that flexibility and the power of T-SQL to manage and manipulate the data and give you better performance no matter what the size of the data that you're talking about. And like I mentioned about logical data warehouse, so it's not just ad hoc SQL. You can actually create a logical data warehouse of the data. So let's say your data is sitting in Azure storage in form of files. You create tables and views on top of that as logical data warehouse. And then you can use your familiar BI tools, Power BI or Azure Analytics services, or any other tool that works with SQL. You can use that to query the data and do complex data processing, joining, and aggregation on top of your raw files without pulling the data in, right? That's the key here. So when you want to keep the data in place and you want to run transformations and analytics on the data without moving the data or without duplicating the data, this provides you that functionality. Serverless provides you the functionality there. So here's how you can create a view. So you can create a logical view on top of. So this is the, let's say this is the query you're running to explore the data of CSV data sitting in your storage account. You can create a view on top of that. So from that point onwards, you don't have to run this query. So you can directly query the view, and the view is going to pull the data. And so for your SQL tools, it looks like any other SQL view, but the data is not persisting in your database. It is actually coming from your external storage or data lake storage. Same thing with tables. You can create external tables. So you can create an external table on top of the data sitting in your data lake, and then you can create statistics on that data as if it is the data like a traditional table. You can create statistics to improve performance, and then you can query the data, select the data from that external table, which will automatically point to the location where the data is stored in your data lake storage, and then pull the data and provide better performance because of, by creating statistics on top of that. And then you can even create Power BI reports on the views or tables created on external data, again, without persisting the data. So it's a very good use case scenario when you want to when you're pulling large amounts of data into your data lake store and you want to run analytics on top of that in place, or transformations or Power BI reports, or any type of BI reporting, you can do all that without persisting the data into a traditional relational store. And then like I mentioned, again, data transformation. So you can do also easy data transformation on the data, again, without pulling the data anywhere else. You just run simple T-SQL to, for example, convert a CSV file into Parquet. So you can do that using serverless SQL pool, or you want to move data from one folder to the other, or you want to repartition the data, or you want to query the, run some complex SQL and store the results of the data back into storage. You can do all that. And you can also create ETL pipelines using SQL commands to transform the data, change the SQL statements, materialize your reports on the current snapshot of data. All that is possible using the serverless SQL pool functionality. And CETAS, create external tables. So you can also do some transformations using CETAS. So like I mentioned, you can run a query, and you can, on top of that, the data, you want to persist the data of the result of a query. So you can create an external table with the result of that query. So now you have the data sitting in with the result. So you don't have to run this. If it is a complex query, you don't have to run the query over and over. You actually materialize or persist the data of the result of the query. So you can now simply run the query on that external table, so which is giving you the result of that complex query that you ran before. Okay. So this way you can pre-calculate and store the results of query and store them permanently, and then retrieve it whenever you need the data with the better performance. And then Spark, so like I said, so there is continuous seamless integration between Spark and SQL runtime. So you don't have to use one or the other. So you can get the best of both, Spark engine for big data analytics versus SQL engine for relational and other types of analytics. So yes, but you can, for example, if you created a table in Spark pool using the Spark engine, so you create a table, you can have that seamlessly available to query from your serverless SQL pool, right? So that's how, so you can seamlessly connect, and if you are doing some some complex transformations or using the Spark engine, you created tables with the result of that transformation. You can now switch to say serverless and query the data from that using the traditional SQL T-SQL language of that transformed data that was previously created using a Spark engine. So that's the kind of seamless functionality between Spark and any updates. If you do some Spark table updates, those are applied in serverless SQL pool. So you don't need to manually create SQL tables, then match with Spark tables. It all happens seamlessly.
Sorry,
and
Carl,
Spark.
just a short notice regarding the time.
Yes. Yeah.
Sorry for it.
Yeah.
Please?
Thank you. Thanks for the. So yeah, I will just give me a few more minutes. I'll finish and then open up for questions.
Sure.
All right, and then there are several clients tools available. So like I said, Synapse Studio is one of the common ones you'll use for your data development and data manipulation. But you also have other tools that, if you're familiar with Data Studio or Management Studio, you can use them, or you can use Power BI, Azure Analytics services, and all that. And then developer tools, you can use any of your familiar developer tools. So going into switching from SQL engine to Spark engine, again, that is also integrated into your Synapse Analytics. So if you have big data analytics that need to be done, you can use the Spark engine for that purpose. Again, it's not one or the other. You can use a combination of Spark and SQL in your modern data warehouse or data lakehouse architecture. excuse me. So we support Spark 3.1, Apache Spark 3.1 derivation, so which means you'll get all the benefits of what Apache Spark 3.1 provides, such as Delta Lake 0.8 support, ANSI SQL support, and it is tightly coupled with your other Azure Synapse services. So integrated security, metadata, simplified provisioning, and the all these helps with your core scenarios like data preparation, data engineering, machine learning, and it is extensible through library management. It provides efficient resource utilization via fast start, auto scale, auto pause, and then not to mention the multi-language support. So be it .NET, PySpark, Scala, whatever the language you're familiar with or whatever the language more suitable, you can use part of this Synapse Spark, which is based on Apache Spark. So for those of you familiar with Apache Spark, you know what all the Apache Spark brings in: Spark SQL for batch processing, machine learning for Spark MLib, Spark streaming or GraphX. All those are available as part of your Spark Synapse Spark engine. So these are some of the features. I will let you, I'll share this deck anyway, so you can go through this. In the interest of time, I'm not planning to go through all that. But also, so yeah, while creating, so you can, like I've showed you before, you can use Synapse Studio to manage and your Spark or SQL engine. So the Spark pool, you can create and manage your Spark pool from Synapse Studio itself, and you can specify your node size, you can enable auto scale and specify the number of nodes. You can also specify auto pause, when to pause, like after how many minutes of idle time, and what Apache Spark version you want to use. And you can also import packages. All that is available as part of your Spark engine. Okay, so that's about the engines available and how and when to use. Now, taking it further again, beyond that, if you have functionality that is not directly available with your Synapse SQL or Spark functionality, you can, for example, Cosmos DB. So if you're doing cloud native hybrid transactional analytical processing, where or if you're doing in place analytics or operational data, Cosmos DB may be a better option, right? But when you do that, so it doesn't mean that, okay, so you're stuck with, okay, so you, in a silo where you do your operational data analytics in Cosmos DB, but you cannot do anything about Synapse in that scenario. So using Synapse Link, you can actually pull the data and work with that data, operational data from Cosmos DB using either Spark engine or SQL engine of Synapse Analytics, right? So that makes it even make your Synapse Analytics even more powerful for your machine learning or big data analytics, or for BI. You can use the integration between Cosmos DB and Synapse Analytics for your for providing that best of both worlds, right? Again, without going into different tools or different places to get what you need, right? So using this modern data warehouse architecture with Synapse Link, you can read and write data, operational data coming into your Azure Cosmos DB for SQL, using SQL tables or Spark tables, and manipulate and handle with the Spark functionality. So real quick, some of use cases where it would be useful, right? For example, let's take supply chain analytics. So you have data, operational data coming from online shoppers and batch files and logistic telemetry. So you can pull that all into your Azure Cosmos DB, and then using Synapse Link, you can handle the data using either Synapse Serverless and or Synapse Spark for and run machine learning analytics on top of the data, and you can generate operational reporting for your store managers and whatnot using that Synapse Link by manipulating and handling that operational data from Cosmos DB into Azure Synapse. Another example, real-time personalization. So you have e-commerce applications, and you want to provide online real-time recommendations based on shopping patterns. You can do that using Cosmos Link as well. I'm sorry, Synapse Link. As your data, you pull in order processing data into Cosmos DB using Synapse Link. You can use Spark processing pipelines to process the data, run analytics, and then send online recommendations in real time to your e-commerce shoppers, right? Same thing, predictive maintenance, IoT. You can use Synapse Link there as well. So as you pull the data from different IoT devices into your Cosmos DB, you can use Synapse Link to pull the data into Synapse Analytics and run analytics on top of that. All right. So these are all some of the the advantages of Azure Synapse Analytics and how it helps you with your big data or analytics or relational data analytics, and provides the best of both worlds. So, be it big data or relational data, be it data warehouse you're talking about or lake house. So Azure Synapse Analytics provides you all those advantages with a single pane of glass experience for your analytical needs. With that, I'll stop here.
Okay, thank you very much, Carl. We had just a short question. What can we use as a data source which we can pull into Azure Synapse? Are those only Microsoft only products, or we can pull the data even from third-party products?
That's a very good question. Yes, you can pull the data from third-party products as well. So like I mentioned before, Synapse Pipelines has connectors, 90 plus connectors available for different types of sources of data, be it Oracle or Teradata or even competing platforms like Redshift. So you can pull the data from any of those sources, and pretty much any even if it is not directly available as a source, any ODBC supported sources, and yeah, so you can pull it from different sources.
Okay, excellent. Thank you very much once again, Carl, for joining with us and telling us the whole story regarding Azure Synapse. I will just now switch the language just to say hello to our attendees so we can continue further. Thank you once again.
Thank you.